The first thing is you have to understand what is the meaning of brain. What is the meaning of brain or neural network of the brain? Okay, so based on that thing, we are convert that to biological neuron into artificial neural networks. So here we are understanding the human brain. So based on the human perform the different tasks on simultaneously on the same time. Okay, now you perform the multiple tasks like sometimes listening, like seeing. Okay, and talking, everything we are performing multiple tasks. This is done with the help of our normal human brain. So here human brain contains different neurons are there. All these neurons are interlinked each other. Okay, now interconnected with each other. So simply this is the human brain, and this is the neurons of the interconnected neurons are there, and this is a small part of the interconnected neurons. And coming to this one, this is a simple neuron, single neuron. Okay, now single neuron. And see this one, this is the what we call biological neuron. What we call biological neuron. Now so here these are called as a dendrites, and this is called as a nucleus, and these are called as a dendrites, and this is the entire thing is called a cell body. Okay, now for example x1, x2, and x3, and x4, x5, and x6, x7. That means this neuron, this say nucleus, or this neuron is going to be connected from the connect with the different other neurons. Okay, it reads the information from the other neurons like x1, x2, and x4, x5, and x6. All these x6 all are called as input for this nucleus, and here it performs the summation of the all the input and perform some operation. Then output is going to be forward to the next layer as input to the other neurons. Like that we are going to perform the things. So simply this is called as a neuron. The neuron contains nucleus, dendrites, axon. Axon is the carry the output of the one neuron to the other neuron. Okay, as a input for the other next neuron. So simply this is the overall view of the our single neuron. Based on this only, we are going to convert that into artificial neural network. Whatever the ends are there, that is based on the our biological neuron only. Okay, now so this is a single neuron only, single neuron. Now this single neuron, for the single neuron, this is one single neuron. For the single neuron, we are going to give the input from the x1, x2, and x3. Okay, now x3 and so on. How many neurons are there here? For example, how many inputs are there? X6. Based on the 6 inputs, okay, and we are going to perform the some operation, and then activation function is there. We are going to get the output. Okay, so this is the overall structure of the our. Normally, this is what we call. This is called as a biological neuron that is converted into artificial neuron. Okay, now artificial neural networks. We will see everything. Okay, now this is the what we call artificial neural networks. For the artificial neural network, it contains one neuron is there. Okay, for this neuron, we are going to get the input from the different sources like x1, x2, and suppose for example here three inputs are there, and then we are going to perform the sigma operation. Then we are going to get the activation function, and then we are going to get the output. Y cap is nothing but your output. So here, for example, in order to pass in the examination, okay, suppose we are having the 3 subjects are there, like we are x1 one subject, x2 one subject, and x3 one subject. All the subjects are not equal. Okay, for some one person, x1 subject is very easy, x2 subject is very tough, and x3 subject is medium tough. Okay, so at that time we are putting some less effort on the x1 subject, and we are putting some high weight on the x2 subject, and medium time in order to complete that subject is W3. Okay, so the weights are going to be acting as a interlaid between the input and the input neurons. Okay, now so that means how much of effort you are going to put on the corresponding input value x1, x2, x3. These are called as weights. And now for this example here, for example here, now what we call x1 into W1 plus x2 into W2 plus x3 into W3. This is the our function. Now at the same time we are going to add some bias value there. Some we are adding the some bias value. Bias is the gives the output. Okay. On this input value, we are going to perform some activation function. We are going to perform the some activation function. We will see what is the meaning of activation function, and then we are going to get the y cap. Y cap is nothing but your output value. Okay, now based on the x1 on w1 plus x2 on w2 plus x3 on w3 on plus w value, we are going to get the new corresponding output value. This is the our predicted output value. So simply this is the structure of the your input value, your artificial neural networks. So simply you can write this as a f of sigma of x1 xi wi plus bias value. Okay, xi nothing but your input value and corresponding weight work on the corresponding input value plus bias value. On that entire input values, we are going to perform the some activation function. Okay, we will see what is the things. Now here, whatever the biological neurons are there, that is converted into artificial neural network now. So this concept was proposed by the John J. Hofield and Jeffrey Hinton. So because of them only nowadays we are using the deep learning concept, whatever may be. Okay. So in the last year they got the Nobel Prize for the invention of this artificial neural networks. Okay now. Now, in order to understand the basic concepts of these things, first of all, we'll see what is meaning of how we work out on all these things. Okay. So, for example, here it contains. Now, we'll see one example. Then we can understand. This is simple neural networks. Single neuron. So, how many inputs are there? For example, here x1, x2, and x3. Three inputs are there, and each input contains some weights are there. W1, W2 and W3, and here we are having the some function summation is there, and we are having the activation function is there, and then we are going to get the output y cap is there. This is the very predicted value. Simply this is called simple neural networks. How we are going to input we are going to perform input we are performing the operation from the input layer to the output layer. Simply this is called as a forward propagation. What we call forward propagation. That means first of all you have to perform the x1 w1 plus x2 w2 plus x3 into w3. Then you have to apply the activation function. Then we are going to perform the get the output y value. Okay now. So okay now. Now in this part we are having the these are called as input layer. These are called as your input layer. And this is called your output layer. This is called your output layer. This is called your input layer. In between, here we are having the one layer is there. That layer is called as a. Okay, that layer is called as hidden layer. Hidden layer. How many hidden layers are there here? Only one hidden layer there. That contains only one neuron is there. This simply it is called a simple neural network. Simple neural networks, or simply it is called one type. Only one neuron is there. For this neuron, we are going to give the input and we are going to predict the output. Okay now. Now, what is meaning of multi-layer perceptron? Multi-layer perceptron. Okay now. So that means here x1, okay, x2 and x3. For example, x4 and x5. These are the 5 inputs are there. And now here these are called as input. Okay, input layer. And here we are having the 1, 2, 3. 3 inputs are 3 neurons are there, and 2 neurons are there. This is the output layer. Now here see this one, see the diagram here. Okay, now this is called as your how many neurons are there? This is the input layer, and this is your output layer. Okay, now here it contains 3 neurons, and this is called as 2 neurons, and this is called as 1 neuron. This is your output layer. Okay, it is a output y cap. Now each and every neuron is going to be connected with each and every input is going to be connected with each and every neuron. Okay now. So see this one. What is the neuron here? Neuron. What is the purpose of the neuron? Neuron is going to perform the both summation and activation function is going to be performed by the single neuron. That means here it performs the summation and the activation function, summation, activation function, summation and the activation function. Then this output is going to convert into next layer as input. Okay, this output is going to give into next layer as a input. Okay, now. Okay, so here you are going to perform the summation, activation function, summation and the activation function. This output is going to give into next layer as a input. Okay, now. So summation and the activation function. Like that, we are going to get the corresponding feature. For example, here, for example, we are giving the input as a one banana. Okay, banana something. Okay, that corresponding x1 is there, x2 is there, and x3, x4, x5. These are called as a features of the our input to features of the our input to things. Okay, based on the features, we are going to print the corresponding class label. So in between the features and the output, we are having the hidden layer 1 and hidden layer 2.
Hi, how are you?
Hidden layer 2. Like that, we are having the n number of hidden layers are there. We can create n number of hidden layers, and each hidden layer contains n number of neurons are there. Okay, now. So each neuron perform the sigma operation, summation operation, and then followed by the activation function. Okay, so in order to understand this one, so simply this is called as a it is called a simple or single neuron perceptron. Okay, now simple neural network, simple neural network, and this is called as a multi-layer perceptron, multi-layer neural network, multi-layer perceptron. Okay, now. So here that means between the input and output we are having the multiple hidden layers are there. Okay, now simply this is called as a multi-layer perceptron. Now in order to understand this one, we are going to look into the what is meaning of things. Okay, so here this is the one playground is there in order to understand the neural networks. So see this one. This is for example, there are some sample data set is there. Sample data set is there, and there is some sample data set. Our aim is, for example, this is the data set. Okay. Now here it contains only two features are there. One is blue color is there, and one is orange color is there. Okay, now that the shape of the input features. Okay, here x1 and x2, there two features are there, and here our aim is we are going to predict we have to separate the blue points separately with help of compared to orange color points. Okay, now in order to perform this one, we are going to use the hidden layer. Okay, hidden layer. So now here we are going to create the only one neuron. So here the x1 is one feature and x2 one feature is two features are there, and here only we are creating one neuron between the input features and the corresponding output features. Okay, now with the help of this one, what happened? Okay, we are going to separate these separate the blue color points and orange color points. So now here, see this one, these are called epoch. Epoch nothing but a number of iterations. What we call iteration. Okay, like for loop is there now, for like that for loop, if loop like that. Okay, here they are checking the condition. Okay, epoch means a number of iterations. Then we are having the one more thing. Already we discussed that one. Okay, in the hidden layer. Okay, we are having the activation function is there now. So here the activation functions are ReLU, Tanh, Sigmoid, and linear. All are they called as a different types of activation functions. And then here the problem is here called as a whether it is a classification problem or regression problem. Our aim is a classification problem. Now with the help of this one, see this one, we are using the Tanh activation function. We are using the Tanh activation function, and then we are applying the total loss learning rate. With the help of learning rate is nothing but a one type of how much amount of time is required or thing is called as a learning rate. Okay, see this one. What happened here? We are performing the n number of iterations. Folks are there. Okay, see this one. The learning is going on, so it automatically classify the blue points and the orange points separately. But it takes a lot of time. in order to overcome this problem, we are going to use the hidden layers too. We are going to increase the number of hidden layers. So once I can check this one, okay. So here, but it is not unable to classify the perfectly. Okay. So now in order to increase the performance accuracy model, we are going to increase the hidden layers. Okay, hidden layers. So see this one automatically you are going to increase the accuracy. Okay, if you increase the number of hidden layers between the input layer and output layer, automatically it classify the blue points separately and orange points separately. Okay, you can increase the n number of neurons, n number of hidden layers between the input layer and output layer. Okay. Okay, na? So this is done with the help of what we call see this one. These are the inputs and these are called as your header layer 1 and this is called your header layer 2. Okay, na? And this is your output layer. So in by increasing the number of neurons in the hidden layers, automatically we are going to get the better output. Okay, na? So this is simply one type of simulation tool is there. I will share the link, and based on that link, we are going to conduct the perform different types of tasks. Then we can understand what is the how we are performing the artificial neural network. Okay, now? So see this one. By increasing the number of epochs, we are going to get the better output. Okay, now? So the loss is initially the loss is very high, while the epochs are going on, the loss is going to be decreases and the accuracy is going to be increases. Okay, while the number of epochs are increases. So like that, you can change the equation functions here and perform the task. Once again, we're going to get the better results. Okay, now. So you can try this tool. We can understand how we are performing the artificial neural networks. Now, so this is about the artificial neural networks. Now, hello,
Sir.
audible, sir.
Audible, sir.
Yes, sir. Yes, sir.
Okay.
Audible,
Now,
sir.
Continue.
This is the what we call already we discussed about the multi-layer perceptron. Okay, multi-layer perceptron. These are the input layers. Sorry. These are the input layers, and this is your output layer. Okay, output layer. Here in between we are having the hidden layer 1. Okay, and the hidden layer 2. In the hidden layer, these are the input of the your input features of the your input data. Based on that, each and every input is going to be connected to each and every neuron in the hidden layer. Okay, hidden layer. So the xi1 is connected to f1, for example f1, f2, f3, and f4. There are the four neurons are there in the hidden layer 1. So x1 is connected to each and every input neurons, and xi2 also connected to all the neurons in the hidden layer 2. Like that, simply this is called as a one type of network. This network is called as a fully connected network. What we call fully connected network, or this also called as a dense layer, dense layer. What we call dense layer. The dense layer nothing but the input is connected to input feature is connected to each and every neuron in the next layer. This is called as a simply fully connected layer. Okay, now like that the output of the hidden layer 1 is neurons are connected to input to the layers in the neurons in the next layer. Okay, so this also fully connected network. Like that, we can between the input and the output, we are going to increase the we can add n number of hidden layers and n number of neurons on the each and every neuron. That is a very important concept. Okay, now. So, but in order to understand this one, first of all, we have to know what the neuron performs. The neuron performs two operations. One is sigmoid, one is activation function. These are the very important two steps you have performing the neuron. One is sigma. Sigma nothing but here for the F1, for example, F1, what are the inputs? xi1 and corresponding W1, xi2, W2, xi3, W3, and xi4, W4. So like that, all these summation of input features and corresponding weight values is called as a summation. On that input value, okay, we are applying the some activation function. Okay, the activation function triggers the output of the sigma activation sigma summation output. Okay, and it delivers the output in the form of a linear fashion or non-linear fashion. Okay, to the next layer as a input to the next neuron. Okay, so now for example we'll see one example here. F of x equal to and 2 into sin x square plus square root of 5x. Now this is a simple example how we are going to convert that into neural networks. Okay, now or simple network model. So here we are going to perform two operations, like one is f1 is a one function that is called add, and f2 nothing but a square function, f3 nothing but a square root function, and f4 nothing but a sine function, and f5 nothing but a multiplication function. So like that we are going to divide the entire problem into small functions, and then we are going to combine that into single network. Okay, so see this one here. What are the input for here? Our model 2 is one input, and x is one input, and 5 is the input. Okay, so 2 are x and 5 are our input features. On the input features, we are going to perform the different types of operations. Okay, first thing is we are going to perform the multiplication. X is multiplied to 5, that we get the 5x. Okay, on that we are going to apply square root function. So for example, this is one neuron, multiplication one neuron, square root is one neuron. Now 5 square root of 5x. Okay, then here we are going to perform the square x. Okay, then we get the x square. Then we are going to get the on that x square as input, we are going to get the sine function. Then we are going to get the sin x square. Then we are going to perform the 2 into sin x square. Okay, so that is a 2 into sin x square. Then we are going to add the things, and then we are going to get the add the root to 5x plus 2 sin x square. We are going to get the 2 plus 2 into sin x square plus root square root of 5x. Then this is your output value. So like that here each and every neuron circle is acting like a one neuron. Okay, this is for the simple understanding of the neural network. Okay, now so in order to understand large problems, so okay, here we are having the different inputs are there. This is input layer, and this is our output layer, and then we are going to get the input as a x0, x1, x2, and x3. This is the input values, and here our neuron is there. The neuron perform the x0 into wij plus, okay, and x1 into wj. Like that we are going to perform the neurons, and number of neurons are there. This is simply described as two hidden layers are there. Hidden layer 1 and hidden layer 2 is there. Two hidden layers are there between the input layer and the output layer. Okay, now this is the these are called activation function. This is the signal. So like that in each and every hidden layer we are having the n number of neurons are there. Here 3 neurons are there. Here also 3 neurons are there. Like that we can increase the number of neurons between the one layer to other layer. So here also we are using the bias is a one function you are going to add to the each and every neuron. Bias is going to use to simulate perform the better results. We are going to add the bias value. Okay, so finally we are having the output layer. In the output layer we are going to predict the one. Here we are using the only one neuron is there. So here in the neuron output neuron we are having the different types of activation functions are there. According to our problem statement, we are going to use the whether it is a Sigmoid activation function or a Softmax as a activation function. Okay, so the neural network is nothing but a collection of neurons between the input layer and the output layer. These are the things. Okay, now so now sometimes what happened now. So this is the one type of network is there. So here this is a fully connected network. Okay, what is meaning of fully connected network? Anybody? What is meaning of fully connected network? The input is connected to each and every neuron on the next layer is called as a fully connected network. Okay, now so this is one type of fully connected network. Okay, now And then what is meaning of there are two things are there. One is back propagation is there. Okay, now back propagation is there. You see an example. Then you can use. So for example, there are two things are there in the artificial neural networks. The first thing is called as a forward propagation, and the second one is called as a backward propagation. What do you mean of forward propagation? For example, simple neural networks. Suppose, for example, here only two neurons are there. Only one neuron is there. Suppose two inputs are there, x1 and x2. Two inputs are there, and the corresponding weights are w1 and w2 is there. Okay, and corresponding summation and corresponding activation function. Then we are going to get the output y cap. Now, y cap is nothing but a, what is the formula now? What is the forward propagation? The forward propagation nothing but a, you are going to get the output from the input to the output. Okay, the forward propagation. That means you are perform the x1 w1 plus x2 w2. Okay, and then there is some bias is there, bias also there, and then on that we are going to some activation function f, that is called as y cap. This is y cap is called as your predicted value, what we call predicted value. Now, for example, if any there is a actual value is there, the actual value and predicted both are if both are the same, then the loss is going to be 0. What is the meaning of loss? The difference between the actual value, okay, minus predicted value. So here the actual value we call as a y and predicted value we call as a y cap. Okay, if there is small difference between the y and y cap, that means actual value and predicted value. So simply that is called as a loss function. What we call loss function. Okay, after predicting the output value with respect to forward propagation, with help of forward propagation, okay, we are predicting the loss function. If any loss is there, our aim is we have to minimize the loss function. Okay, now in order to minimize the loss function, we are going to differentiate with respect to, the input values are fixed value. We cannot change the values of x1 and x2 value. We can change the values of only w1 and w2 only. Okay, so now in order to minimize the loss function, what happened now? In the first iteration, in the first epoch value, we are finding the y cap value. Now comparing the actual value with the predicted value. If both are the same values, then we can stop the process. If both are the different value, at that time there is some loss is there. In order to minimize that loss, okay, we have to go back to our input values. Okay, that in the backward propagation, what we call backward propagation, and then we are going to update with the weight values with respect to back propagation, derivative of loss with respect of derivative of y cap. That y cap is depends on the f value. That means derivative of f with respect to derivative of y cap. Now this is f is depends on the two values. Okay, now. So that means derivative of w1 with respect to derivative w2 with respect to derivative of f, and derivative of w1 with respect to derivative of f. Okay, simply that process is, after that what happens, the w1 and w2 are going to be changes. Initially we are assigning some randomly we are assigning some weight values, w1 and w2 value. Now with the help of loss function we are updating the weight values. Okay, now with the updated weight values, once again we are going in a forward propagation. That means once again we are finding the x1 w1 plus x2 w2 and so on. Okay, then update the weight, predict the new weight value, new y cap value, and once again find out the loss function with the new predicted value and the actual value. If compared to previous loss function, now we are going to get the less losses there. Okay, now. So that means in one iteration we are going to minimize the loss function, minimize the error. So like that, we are continuing the update the weight values until the new weight value until the new predicted value and the actual value are going to be similar. Okay, convergent. Okay, now. So simply the process is called as a back propagation. What we call back propagation. So see this one. This is the input values, and here n number of hidden layers are there. Each hidden layer contains n number of neurons are there. Okay, now n number of neurons are there. We are going to predict the output value. Now we are going to compare the predict the loss function with respect to your actual value and predicted value. If any loss is there, then at that time we are going to in a backward back propagation. Okay, in order to update the your weight values w1 and w2 are like the n number of weights are there and that works on the our input values. Okay, now we have to change the weight values until okay we are going to get the less error. So simply the process is called as a back propagation. Is it clear? Now, so in order to implement the artificial neural networks in a program point of view, okay, not developing a program, okay, we require the some activation functions are there and some optimizers are there, okay. So here the activation uh, TensorFlow dot keras on the top of TensorFlow there is a keras are there. On the keras we're having the different types of activation functions are there. So here the activation functions are there like ReLU, okay na, and ReLU, Sigmoid, okay na, Softmax. They are the regularly used activation functions, okay na. Sigmoid, Softmax, ReLU, okay, a linear activation function, leaky ReLU. Like that, we're having different types of activation functions are there, and each function perform different types of values, okay na. And then here also we're having the optimizers are there. In order to minimize the optimization, okay, loss function, okay, we are going to use the different types of optimizers are there like ADA delta, okay, ADA factor, ADA grad, ADAM W, like the ADA max, okay, optimizers, RMS propagation, stochastic gradient descent algorithm, N ADAM, loss scale optimizer, like that we're having the different types of activation functions are there. Now we are going to implement this model in our experiment. Okay. Now see these are the activation functions. Already you know the x1. This is our neuron sigma, and here x1 is there, one input, x2 is there, and w1 is there, and w2 is there. X1 and x2 are fixed values. We cannot change the fixed values. We can change them only w1, w2 only. Okay now. So here this is the called as a activation function f. F is called as a activation function. F according to our problem statement we can use the linear activation function or okay sigmoid activation function. What is the meaning of linear function? If x is equal to 1, f of x also going to be get output as a 1. Simply it is called as a linear activation function. Okay now so that means suppose here suppose this is called as a your summation. Okay, for example here what we call f of sigma, f of sigma equal to summation of x1 and x2 with corresponding weight values. Okay, the sigma equal, for example sigma equal to 1 value, then automatically f of sigma equal to we'll get the output as a 1 only. So then that is called as a linear activation function. That means input and output both are the same things only. Okay now then we are going to get the other model activation function called as a sigmoid activation function. The formula for sigmoid activation function is okay 1 by 1 plus e power minus x. Okay now 1 by 1 plus e power minus x, that value between the 0 to 1 only. Okay now 0 to, this is in the form of a s curve, this is in the form of a x curve. Okay now so that means suppose for example of performing this one, f of sigma equal to, for example here x is nothing but sigma. Okay, then at that time 1 by 1 plus e power minus sigma. Sigma at the your summation output. Okay, the summation of your x1 w1 plus x2 and w2. Okay, now this value is given to sigma. Then at that time we are going to get the value as a your between the 0 to 1. And then one more activation function is there, that is called as a tan h. Tan h nothing but f of x equal to e power x minus e power minus x by e power x plus e power minus x. That is the tan h equation function. And then ReLU is a one more equation function is a ReLU. Okay, here maximum of, for example, x equal to your input value equal to of performing the f of x equal to that is f of sigma. Okay, now one just wait. X1, X2, W1, W2. This is a sigma. Sigma, what is sigma equal to? X1, W1 plus X2, W2. For example, now we are going to perform the activation function f. Now, how can we perform the activation function f of sigma? If the sigma value of performing this value, suppose the sigma equal to -1. Now at the time, what the ReLU activation function performs? ReLU activation function is f of sigma equal to maximum of 0 comma sigma. What is sigma value? Sigma equal to what the -1. So what is maximum of 0 comma -1, that is equal to 0. That is the output we are going to get. Suppose here we are going to get the value as a 2, for example. So at that time we are going to get the max of 0 comma sigma. Sigma, what is sigma value? Max of 0 comma max sigma equal to 2 na. So that is equal to, we get the output as a 2 value. Like that we are going to get the according to problem statement we are going to get the apply the tan h function or ReLU activation function, okay, or Sigmoid activation function, linear activation function, or Softmax activation function. Leak ReLU also one type of activation function there. So all these things are applied on your neural networks. Okay, now your neural networks. So in order to the basic thing is only neuron we have to understand. Okay, now x1, x2, w1, w2, and the activation function f I cap. Okay, now so this is the very this f is college. Here we are going to use the leak ReLU or Softmax or tan h ReLU or linear activation function or Sigmoid activation function. Like that we are going to apply our activation functions. Now in the output layer, for example, if the output contains multi-class classification problem, at that time we don't know which is your output. At that time we are going to use the Softmax as a activation function. Softmax as a activation function in the output layer. In the multi-class classification problem and multi-layer perceptron problem, we are using the Softmax as a activation function in your output layer. Okay, now in order to find out this one, for example, here they are the input values, they are the output layer. Okay, in the output layer we are having these are the output values. So now we are going to predict what is the probability which is the having the highest value. Okay, according to that we are going to prove the corresponding class label. Now for example, here in the output layer we are having the 1.3, 5.1, 2.2, 0.7 and 1.1. For each and every input value you have to predict the corresponding probability. So what is the formula for this one? E power zi by sigma of j equal to 1 to e power zj. Okay, now that means here for example we are considering the first value. That means e power 1.3 by e power 1.3 plus e power 5.1 plus e power 2.2 plus e power 0.7 plus e power 1.1. Like that you have performed the probability of this one. Now after performing this one, what we get? 0.02. Like that we are finding out the value for the 5.1. Like that we find out the value for the 2.2, 0.7, like that 1.1. So after finding the Softmax probability values with the help of Softmax activation function, we are getting the 0.02, okay, 0.90, so 0.90, 0.05, 0.01, 0.02. Among all these 5 values, 0.90 is the highest value. So now whatever the class label corresponding this value, that becomes your output. Okay, now So like that, in multi-class classification problem, we are going to use the softmax as a activation function. For example, here, okay. For example, here we are giving the input as a handwritten digit like we are having the handwritten digits like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, they are the multi-class classification problem. Okay, we are giving the multi-class classification problem. So here it contains 10 different classes are there. 10 different classes. What are different classes now? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For example, your model is there. This is the for the ANN. For the ANN, we are giving the input as a for example, this is a what we call, we are giving the input as a 5 as input for the our model. Now the model is going to be predict the multiple classes. What are multiple classes here? Either it may be 0 or 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now the input is mapped to any one of these multi classes, either 0 to 9. Now, in order to find out this corresponding class label, what the actual class label of 5? In order to predict the corresponding class label, we are going to use in the output layer, we are going to use the softmax as a activation function. In the softmax, if you are using softmax activation function, we are going to get the more highest probability value for this at the location of the 5. And for the remaining values, we are going, for example, here getting the 0 0.1, 0 0.01, okay, 0 0.101, okay, 0 0.01 and 0. Okay, like that we're going to values, but coming to here 0.9, okay, and 0.1, okay, 0.01, like that we are going to get the multiple values. But here at the location, at the fifth location, we're going to get the highest value. So based on this highest value, that means it finds out the what we call the corresponding class level. Okay, now so like that in the multiple classification problem, multi-class classification problem, we are going to use the activation function as a softmax as a activation function. Okay, so now see this one here. This is the, for example, your multi-class classification problem. In the output layer, we are going to use the activation function as a softmax. What is the softmax activation function formula? e power x by, okay, sigma of e power x. This is your softmax activation formula. Okay, now. So now in the normally in the hidden layer, we are going to use the activation function as a ReLU, Sigmoid, and Tanh. You can use any one of the activation function in the hidden layers. Okay, in the hidden layers. This is one hidden layer. In the hidden layer, having the 3 neurons are there now. This hidden layer 2 also we have the number 3 hidden layers neurons are there. For each neuron, we are going to use the, either it may be a ReLU activation function, Sigmoid activation function, or Tanh activation function. But coming to your output layer, we are going to use the activation function as a suppose if it is a regression problem, then we are going to use the linear activation function as a activation function in the output layer. Suppose it is a binary class classification problem, then we are going to use the, we can use either it is a Sigmoid activation function or a logistic activation function. Suppose if it is a multi-class classification problem, okay, then at that time you have to use the softmax as a activation function. Okay, now. So this is the way you have to use the different types of activation functions in your neural networks. In the maximum case, in the maximum cases, okay, in the output layer, we are going to use the softmax as a activation function, softmax. In the hidden layers, okay, in the hidden layers, we are going to use the ReLU or Tanh or Sigmoid as a activation functions. Okay, now. So this is the thumb rule for the, in order to develop a artificial neural network programs. Now, so sometimes here we are not there is a concept called as a overfitting and underfitting. Okay, in order to avoid the overfitting and underfitting problems, sometimes we have to drop the some neurons in the neural hidden layers. So simply this is called as a dropout. What we call dropout. For example, here what happened now? This is the input layer. Okay, this is your output layer. In between we're having the header layer 1 and the header layer 2 is there. Okay, so sometimes in order to overcome the there is a what we call regular uh, in order to overcome the overfitting problem. Okay, so some in the header layer 1 or header layer 2 we are going to drop the some neurons in the your network. Simply this type of thing is called as a drop out. Okay, with the help of dropout we are going to overcome the overfitting problem. Okay, now